You might have heard about this concept called triangulation. This is something you hear quite often if you watch these sci-fi movies or police investigations, and then you have this group of elites that find some criminal or some suspicious person by using this triangulation method. It's really common in sci-fi movies and even series nowadays. So I want to say that it is actually a little bit of a misconception. We don't use triangulation to find necessarily people or things. We use some other method. But I wanted to start with this one because it's also very useful for location-based applications to know how it works, and also to demystify what it is and to show you that it's really not it being used, it just sounds very cool. So these movie industries kind of adopted it for their own purpose. So how triangulation works is, for example, let's assume that you want to build a bridge over this river here. So you want to estimate what is the distance, what is the length of the river, but you don't know exactly, you don't want to cross the river, you don't want to go swimming over it. So how can you do that without crossing the river? Well, assuming you sit on the other side, maybe you take a reference point. I'm taking now this boat on the other side of the river. And then what you have to do is find out that distance somehow. So one way that you can do it is in an orthogonal direction from this initial direction that we see over the river. You have to move. You have to move in this direction and actually measure the distance. So you have to go and measure a certain distance in a certain in an orthogonal direction, and then from the new point you must only look at the same reference point at the beginning and calculate the angle somehow. Usually this type of protractor can be simply used. So if you have this length, this 100 meter length on the other side of the river, and if you have that angle, it basically turns into this kind of simple trigonometrical problem. So how do we find x assuming these variables? It's not very complicated. One way of doing it is using the tangent. So this tangent formula is of an angle is the opposite length divided by, this, how do you call it in English? So right angle triangle has these two things. Anybody knows how they are called in English or Finnish?
X over 100.
Yeah, it's x over 100, but I wanted to also learn something here. So it's x over 100, but does anybody know what this tangent of 60 degrees equals to? Yeah?
I'm not sure, root 3 by 2, I think.
1.7.
Yeah, how did you do it? You have a device. Okay, so 1.7. Yeah, actually very close. The real answer is square root of 3. It's not divided by 2 anymore. And this equals 7.2 something, a very long number, or 7.3, let's maybe call it that way. So basically, this 1.73 is equal to that, so that means that the x is going to be 173 meters without crossing the river. So this is what triangulation is useful for. It doesn't necessarily give us the position of that boat there. It uses angles, so the reason why it's called triangulation is because it has this angle word inside it. Right, so why did I mention this even though you are not going to position yourself using the method, even though the method is called positioning technologies, the lecture is called positioning technologies, is because in one of the projects you have to do basically that. I'm not sure if you looked at the course projects list yet, but one of them is how to estimate the height of an object using your mobile device. So it's essentially the same thing. If you have this kind of a protractor there, maybe have a weight balancing onto it, then you can calculate, you can get an angle due to this gravity. This angle is actually equal to the angle formed here to the top, but the one on the bottom is just 90 minus the one from the top. So it doesn't really, triangles are great. You can always get these kind of things from them. So now the idea is, could we use the mobile phone to calculate this angle between the user's position on the ground and maybe a tall object far away? Project can be extended, not necessarily to count just the height of an object, but you might also want to calculate some, maybe the width of an object. So anything to do with angles and this kind of triangulation method can be done somehow. Now, since we have this happening here, I think that we can try to implement a small program. Yeah, I think we ordered it like this, and we try to implement a small program that takes the orientation of the mobile device using some of the sensors in the mobile device. So I'm not sure if you know how many sensors there are in some kind of mobile phone, but one of them is very similar to this device here. This is a gyroscope. You probably know what it is. And basically using that we could get this type of angle because the mobile phone, I'm going to try to demonstrate and probably fail miserably, but anyway. Gyroscope has this nice property that it's going to try to maintain its orientation, no matter if you move the phone or not. So basically when you're going to move your phone, it's going to stay at the same orientation, but the phone moving will enable you to calculate an angle here. So basically, we will use a small sensor inside the phone to get this kind of angle information from how you point the device, and you will basically use then the phone as this protractor in your app. So let's see how that works out, and I'm going to try to set up this coding environment here.
Question.
Yes.
Is there that kind of mechanical thing in the phone?
Yes.
Or how? Oh.
Yes. So there is that kind of mechanical thing in the phone. Of course, it's very small, and it actually never stops. So I mean, of course, it stops sometimes, but the phone has battery in it. So the phone actually continues to spin it around. And it also combines this kind of sensor. So this is one sensor, it's the gyroscope. It combines it with the compass sensor. Compass is the same that you use when you do orienteering, this suunnistus. So basically, you can combine them, and then you will have a thing inside your phone that will always point north because of the magnetic North Pole somewhere. So then you also have not necessarily relative positioning, but also absolute positioning due to some fixed reference, in that case the magnetic field. So the phone has many small things inside it, and we will try to use as many things as possible here.
Is it that way that that rounding thing, it has to be somewhere floating?
Yeah. I'm not that technically savvy to explain how they do it, but they do it somehow. It has to do with these electric motors and maybe suspended in some kind of magnetic field. I'm not exactly sure how it works, but it's a very small thing there, and it seems to work. So let's try if we can. Nothing too fancy here, and maybe in the body we can keep something to print out the information. So I'm just going to make a empty div for the moment, but I'm going to give it an ID of output. I'm not going to write anything in it. I'm going to use JavaScript to put the information inside later on, what we are getting, what we are reading from the mobile information, this type of angle. The head part, I'm going to put maybe a title for the page. Something like that. And yeah, I think that's it. So also in the title, in the head area, we are going to write our scripts, so JavaScript. So this goes in the script tag. I'm pretty sure everybody is familiar with HTML. I'm just trying to talk, so it's not just me typing here. And I think we will also do this kind of styling. Let's see if it's needed. Maybe later on. I don't think it's necessary at the moment. So in the script tag, we want to access the device orientation. So this is now some new thing that has been added to HTML. HTML5 is just HTML, but the browsers are just more powerful nowadays. So they decided to name the new features that have entered into HTML as HTML5. So now it's possible that the browser can access from your mobile device information like the location information and this kind of orientation information of the device. So I'm not going to include any fancy libraries here. This is just an empty file that we will build, and you don't have to worry about anything else. It's going to work as a standalone application if you have a modern browser. If you don't have HTML5, if you have a very old Firefox from 10 years ago, it's not going to work. Yeah, so we need to add an event listener to the window object. And this event listener, this should be a constant value, but JavaScript is really not too worried about syntax values, so it accepts this string here. So I can write device orientation in quote, and I'm gonna go on a new line, and what will happen when the device orientation changes, it's gonna be a function that I'm going to call handle orientation, and that's it. So now we write this function called handle orientation. So this function is going to be called every time that the device orientation changes. So it's going to be a function that will be called very, very, very often. And what do we want to do here? Well, actually I don't think I need this anymore. So I want to see what is inside this event information. So I'm going to try to print this event information, and I'm going to print it into this output file. So let's see. I'm going to define a string variable, this output, and now I want to iterate to see what are all the items inside this event information. So in this event object. So I'm going to have a for loop. This will iterate through all the properties of the event object, and I'm going to format them as, okay, let's not use such names. So better variable names. So now I'm going to add to the output the name of the property, and I'm going to concatenate column, and I'm going to concatenate the value of the property. So these things are now going to be added to this output, and I'm also going to add at the end a new line, or in HTML it's this line break. So it's not the backslash n, it's this br tag here. That's it. So now I have an output value, and I want to print it in the output field. So I think in pure JavaScript you have to do something like get element by ID, and then I'm going to get this output here, and then you modify this inner HTML property. You set it to the value of this output. Let's just call it here output string to be more precise. So now, okay. That's it. So now I'm going to go back to the browser. I'm going to try to refresh. Okay, so we have some text here. A lot of text. And if I refresh the page, I'm going to see this one value that changes, this timestamp value. It seems to change all the time when I refresh, but everything else is not working. So I'm now trying to move the laptop around, and it's not picking up any orientation changes. But the reason for that is that this laptop doesn't have a gyroscope inside. So I'm not sure if this will work. Okay. A warning to people who want to also learn the native Android development later on. Start now to install Android Studio on your devices, because it might take a while to get all the things out. So try to install Android Studio, and also run the Hello World project there. We will see later how it's done, but I think after a week and a half. But if you have time, then do that, because it's going to be less of a problem later on. But anyway, I'm going to use from Android Studio this emulator. This simulates a mobile phone on the computer. So I'm going now to simulate zooming in. It's really useful. So now this directory that I have there has also this orientation HTML file, and you can see here that this alpha, beta, gamma values have some numbers here in this emulator. And of course, I still, in theory, cannot move the laptop around to see that the values are changing. But this emulator in Android also has this virtual sensors field here. And if you play with these different values, you see, first of all, it's going to flip my my thing around there, but also it's going to change those numbers a little bit. Now, the reason why those numbers are a little bit changing all the time is because of some noise that has been, I think, added artificially by this emulator, because in real life you will not have totally precise information, so everything is going to be just a little bit of an approximation. But I want you to focus on this beta value here. So now my phone is kind of vertical here, and this beta value has value close to 90, I would say. if I rotate it this way, like putting it down on the table, the beta value turns down to 0. So this is one of the things that you might be able to use in that kind of project. And okay, I think I want at some point to also show you the real device, how it behaves here. But since we are doing now a bit of HTML5, I want to make a little better application for you and to teach you also some other small things. So let's make this a little less boring. Going back to the source code, what we have done here is it's not really handling the orientation. It's more or less printing the output. So I will make another function. And so now I'm also giving a little bit of a lesson about how to code. You should always give proper names to your functions and make them as parameterizable as possible. So for instance here, this function would always output here, but maybe I wanted to put the information somewhere else, so this div will be a parameter for that. I will move this value here. So here I'm saying that I define a div that will contain the output, and now I will call this function print output. Now the event is the same, but the location will be this div file, div object, and this div object here is going to be now the parameter. So I think this should work if I didn't make some mistake. So in the handle orientation now we have the same things, but we have a better named function there. I'm just going to quickly test it, and it seems to be working. But I want to print a little better output. So since we are talking about HTML5, one of the biggest updates that it had is it was this canvas element. So this canvas is similar to a div, but it's going to have some unique properties that we can use. So you define it simply as canvas. I give it an ID. I will call it better output. Canvas here, and now I will make a function that will be something like print better output. So I'm basically okay, event, and now instead of div we will have canvas here. So similar to the print boring output here, but now the better output will use the canvas as the output field. And I'm going to comment out this div from here. I'm not sure if you remember, but commenting in HTML is done like that. I don't like it. Now, printing this, okay. I'm also going to comment out this. I'm not going to need it anymore. It was just for the sake of a coding practice teaching moment. And I'm going to replace it with getting the canvas. So the name of the canvas is better output, and I will call the function print better output to do something with this canvas. So now let's see what this canvas can do. First of all, inside the canvas you need to get something called the context object. This context object is an object that allows you to draw on it, to draw shapes there and modify them somehow. So I'm going to define this context variable, and you get it by calling the method getContext from from the canvas and the 2D context. So this is really cool. The HTML5 has also 3D options, and we will get to that later, even today a little bit. So yeah, so now I have a context, and let's say that I want to draw something on this context. So I can write context, begin path, and maybe let's draw a circle. So context, arc, and now some location. I'm going to give it a location of 50 pixels to the left, 50 pixels from the top. Radius, so this is going to be maybe 30. And now some weird parameters, 0 and 2 multiplied by mat.pi. I will explain these a bit later. And then context stroke. So now that I have this, it doesn't work. So now we find out why it doesn't work. Well, maybe because I'm forgetting here to pass the canvas variable to the function, and I was passing a div that doesn't exist. Okay, now it works. So it just drew a circle, nothing fancy. And one more thing that I use quite often, this is Google Chrome, by the way, but similar features are in other browsers as well. These developer tools, you can activate them by pressing F12 or by going somewhere here. Yeah, this one, or Ctrl-Shift-I apparently. Now, it allows me to check to see what these different items are, so I even see the commented one. But you see that this better output is not that great. It's, I would like it to cover the entire space of the screen, and it's only there in that one corner, so we will have to do something about that also. What I want to do is to get that circle to move as I move the phone. It's more of a visual understanding of how the phone sees the world. So I think it's also a good chance for you to learn what this HTML canvas is like. So how can we do this? Basically, I will create a function that says draw disk. And this draw disk is going to have some parameters again. It's going to have the context as before, a location, and a radius. So I don't like these kind of hard-coded things there, and I want to get rid of them. So basically, I want to order the code a little bit. Context will be as a parameter, and this draw disk is going to have it to be the first parameter here. Then we will need a location variable, which we need to define. And finally, a radius. So the reason why I set these as parameters, so here the x component of the location, the y component of the location, this is going to be the radius, and then these two weird values, which basically say that I want to draw the disk complete. Start from 0 degrees and finish at 2 pi, which in radians means 360. So it's nothing magical there. It's just the fact that HTML5 is allowing you to draw half a disk, or less or more. So it's just something like that. And now this location, let's give it as before, x value of 50, a y value of 50. And the radius, I would give the radius a value that is proportional to the canvas, because here we drew, proportional to the size of the screen, because if you will use a very big screen, then this fixed radius is going to look very small, like almost nothing. And if I'm going to use a small screen, maybe the radius is too big. So this is usually called adaptive design, and you want to have something always look the same, no matter how big is your device. So I'm going to put here, okay, so the location is good like that, but for the radius, I'm going to put a value of, this will make sense somehow. I could put canvas.width, for example, and maybe divide this by 10. So it's always going to be 10% of the width of your screen. Okay, value, maybe we can leave it like that. Could go even farther than that and take the height of the screen also into account. So maybe then you could use something like the minimum value of the canvas height and the canvas width here and divide it by 10. So yeah, so I have now a value for the radius, a value for the location, and something that I really don't, I really didn't like before is that this is not covering the entire screen. So I wanted to cover the entire screen, and to get that to work here where you handle the orientation, maybe we can also force the canvas to be the size of the screen. So we are going to put the width of the canvas to the width of the window. And, oops, something happened. And the height of the canvas to the height of the window. These two are also happening, and I'm really a perfectionist, but I think that you will learn about these things and you will find them useful. Can you see that there is a small empty white space there next to the on top and on the left of the canvas? That's a margin, and I don't like it. So in this developer tools, you can simulate real time as you're playing here CSS. So you could write margin 0 pixels. Oops. Yeah, margin 0, but it's not from the canvas element. It's actually from the body element. So yeah, so putting this margin 0 will solve also that problem. And with this, there we can also learn or remember how CSS is written. So CSS is written in this kind of style tag, and you can write it quite easily. Now we just said that for the body we don't want the margin, so 0 pixels. And let's also make the canvas a different color so that we can see if it's everywhere on the screen or not. So when you use this number sign there, this hashtag, it means that you are going to target an ID of an object. You don't target type, a class, you target the object directly. So now it is this better output ID there. So I'm going to make the background maybe light gray. Now let's see if anything here is different. Okay, so something is different. Now everything is light gray. This better output is everywhere. The circle has now the size that is somehow different depending on how the size of the screen is at the beginning. So this is quite useful when you're doing mobile programming, because the mobile phone sizes have very different ranges. And you really want to have some application that targets everything in the same way, or you don't want to have, like I had here in my emulator, when I went back here, how do I click this? It looks good on my screen, maybe, on the PC screen, but I have to do all this effort to get back to that. So this is just a way to have everything the same size, the same aspect ratio and size on different devices. And now let's go back here. So if you remember, there was this, well, maybe you don't remember, this event property had different values there that were changing. The beta, gamma, some numbers that were changing when I did the simulation before with the emulator. So now I'm going to target that beta variable that was previously, and I'm going to have it modify this location here. Let's put also this location as the canvas width divided by 2 and the y canvas height divided by 2. The reason I'm doing this now is, well, what will happen is that, okay, yeah, so the emulator is also able to do it. So now the circle is in the middle of the screen, so it allows movement in any of the directions, basically. Now I will call this location 0, and the real location information is going to come from the event value. So location of this disk is going to be, well, for the x value, let's keep it simple. Let's just leave it the location 0 x value. So it's not going to move from side to side. Let's just move it from top to bottom. So the I value is going to be relative to this location 0 y, but I'm going to add the value of this beta component. And there are many other components there. You can play with them in your free time or when you study or whatever. So now I'm going to say, get the event, the beta value from this event. And yeah, let's just see how this works. So now I refresh this page, and it gives some error because I have a semicolon here. Yeah. Okay. So you see this circle on the left is now moving a little bit. It's doing some crazy things when I'm playing with this. It basically simulates that the way that you move the mobile phone is going to have an impact on something visual on your phone. So this doesn't help you in your project in any way, but it might enable you to do some other project or whatever in the future. So I think that it would be a good idea for you to play around with this code, and it's quite simple. And I think that because the functions are small and because the names are relatively intuitive, you don't even need comments on this code. How do we find our location with the mobile phone? So this is totally different thing. It's not triangulation. Triangulation is for estimating distances. To find the location using mobile phone, you actually have the distances. So let's see how. I assume that all of you are familiar with this mobile phone signal, because almost everyone I know is angry when it's low. So when is it low? Well, when you're close to some telephone this cell tower, then it's high. But if you go further away from the cell tower, then it becomes low. And there is actually a relationship to this. How does the signal strength vary with distance? A very complicated formula, and it's also not very good in the sense that it's affected by what is around you. Are there trees around you blocking the signal? Are there walls? Are there something? But this is some estimate for that formula, taking into account the signal that you have on your phone and the radius for the cell tower where it works, you can find out how far are you from the cell tower by just changing these variables a little bit. Now this works reasonably well, but what you learn from this is just that the user is somewhere on this circle. So you only know the distance from the cell tower, you don't know where on this circle is the user. So to find out where is the user, you actually need more cell towers. When you have another cell tower, you have a different signal to this other cell tower. Right? This doesn't really show on your phone. On your phone you only see the best signal, the signal from the closest cell tower or the most powerful cell tower, but the network knows that you are one guy using the network and you have this signal from this tower and this signal from another tower, and you can actually download some apps on Android. There are some applications that list you all the cell towers in your area and what is all the signals there. So now that you have two of them and you know how far from each of the cell towers you are, you basically have this other simple math problem, which maybe we can calculate, but I'm going to skip it a little bit. Let's see if we have time later on. And from then you find out that, okay, so the user must be in one of these two places. And to really get the information which one of these two places the user is at, you need the third cell tower. And then that one will give you the real place. Now this is also very theoretical, and it assumes that that function I showed you before is really accurate, which is not. Usually you have something like this, and you find out that the user is somewhere there. This depends very much how many cell towers are around you. More here in the city, less in the countryside. But the accuracy of how to detect the user's location really varies from about 50 meters. 50 meters, it's something, half a football field, all the way to maybe 400 meters. So it's not very accurate, but it's good enough for many location-based apps. If your point is to have an app that shows you the weather information, probably it's going to rain also 400 meters away from you. So it's going to be good enough. Not all of them require very precise information. So this is one way that is happening. And the good thing about this is that the signal from the cell towers are strong enough so they can even penetrate buildings and walls, and you can get location information also here inside. Now, how to improve this? There is a new, well, relatively new technology, maybe 10 years ago, appeared 10 years ago, and this is called cell ID positioning. By the way, trilateration is actually how you find the location, it's not triangulation. So that's a small difference, but some people use the terms interchangeably, and I think it's a mistake. There is even the word triangulateration. So it's a combination of the two, and that means that you use angles and lengths. If you remember our calculation here, you don't have angle to something, you just have distances to something, and you find out the location. So you don't use angles at all to find the location of a user. This cell ID uses also Wi-Fi positioning, and when I said that you have the mobile phone towers, the operators know where the towers are, they built them. But you have more mobile phone operators. You must have a combined database of all these cell towers. So this cell ID is kind of like a combination of all the different cell towers, and even Wi-Fi positioning is now possible. So what is happening really is that you have some services. think about the Google Street View car. Okay, what does the Google Street View car do? It goes around the street, takes pictures everywhere, so that then you can use the browser and learn about the location really well from these kind of images. But it also does something else. It scans for Wi-Fi hotspots. The car has a GPS, it knows its location, but it will learn that when it is in this location, okay, it will learn that this hotspot is close, this cell tower is close, this hotspot is close, and this hotspot is close. And it doesn't just know how close it is, it knows how strong the signal is. So this cell ID database is a database that maps a true location to different cell towers or Wi-Fi hotspots. And yeah, you're going to say that some hotspots will appear, some will disappear. It's true, but in general, there is some consistency there. So even better accuracy can be obtained with these kind of databases, but now internet is required to load the database. So you need to do this matching to the nearest hotspots or cell towers. You need to know where they are. So Google might know them, but your mobile phone has limited memory. It's not going to load all the hotspots from the world. It's going to need now internet to get this kind of database. So this is what cell ID is like. But the real thing is what is now happening is the GPS. Everybody started using these location-based apps, most of the location-based apps when GPS became available. And the first one is the navigation system in the car. Before that, before GPS became available, by the way, GPS existed for a long time, but it was encrypted. The signals were encrypted by the army. So you could get the signals, but they would be unusable for you. But at some point, I don't remember exactly the year, but they removed the encryption. So now it's free for everybody to use. And that's also when the car navigational systems became useful, because you can't use 400-meter accuracy on your car. It's going to tell you to turn, well, when is it going to turn? You really need precise information there. So let's see a little bit about how the global positioning system works. Yeah, maybe we see it this way. Maybe not. Maybe we see this way. Hey, so this is a cool SVG picture. I took it from Wikipedia. I couldn't use that source info, but it's quite nice. It tells a little bit about space and orbits, and you can even highlight these different things there and see what they are. And you might be quite surprised that GPS is here, about 20,000 kilometers up, so really far up. You can fit another Earth between where the Earth is and where the GPS satellites are. These are also GPS things. I think this is the European one, this is Russian one, and this is Chinese one, if I'm not mistaken. They are the same thing, they just have different number of satellites, and well, they also work. Yeah, so they are quite high up, really high up. Hubble is here. And the ISS is here, the International Space Station. So it's actually in the higher levels of the atmosphere. So it's still in the atmosphere of the planet. And yeah, everything has gravity. So gravity doesn't just disappear, it gets weaker as you go away from Earth. But everything still has gravity, and everything is still falling down. But they are moving also to the side really quickly. So when they are moving to the side and they also fall down, they will have this kind of circular orbit or elliptical orbit in some cases. And you see this, the closer you are to the Earth, the faster they move, because the stronger they fall. So the farther away you are, the less fast you need to move. And there is also a sweet spot, quite interesting place here. At this fixed altitude, you have to move exactly with the speed that the Earth is rotating. You don't have to follow the Earth. You can follow the Earth, but you have to be with that speed. If you go any faster, you will go away into space. And if you go slower, you will fall down to Earth. So at each altitude, you must have a specific speed. If you go too fast or too slow, you're going to fall or you're going to go into space. But at this specific altitude, your speed of the satellite matches exactly the Earth's speed of rotating. So if you also match the direction in which it's rotating, you could always have a satellite on top of you that is there at that level. So sometimes weather satellites can be there, but I don't think it's useful because it's so high up that they lose a lot of data from just being far away. Weather satellites are everywhere, it's not just there. But anyway, yeah, so that's just a small thing about satellite information. Oh, oops, wrong computer. But how do satellites position you? It's actually quite simple. You have the satellite there, and it's going to emit something. It's going to emit a signal. And it emits this signal periodically, so it emits it all the time. And what is the information there? It's going to be the time of the satellite and the location of the satellite. So they are the two pieces of information that the satellite is constantly throwing out at you. And what you have is you have a GPS receiver on your phone. So the only thing that your phone is doing is picking up this signal. So let's assume that your phone picks up a signal something like here. Now it picked it up. The time on your mobile phone is going to be time plus 77 in this case. So it took 77 milliseconds for the signal of the satellite to come here. My time on the phone is going to be in the future. The time from the satellite is 77 milliseconds in the past. And the speed of the signal is fixed. It's the speed of light. It's approximately that much. Or since we are talking now in milliseconds, that much. So basically from here to Kuopio in half a millisecond. It's quite fast. Yeah, so that's one thing happening. You have the time, this difference from your mobile phone to the satellite's time, and you can calculate a distance in space using that. So you have the speed, you have the time, you can get the distance quite easily. But then the same thing happens here, like in the mobile phones. You have for the cell towers, you also have another satellite. So this other satellite is also doing the same thing. Let's say somewhere here. So in the first case, we don't have any more a circle, we have a sphere. And now two satellites tell you that you are at the intersection of two spheres. Now, if you know that you are somewhere on the surface of the Earth, you might or you might not be. You might be in space. You might be in on an airplane. It's higher up. It's not. It's I don't know, 8 kilometers up. If you know that you are on the planet, then you're on one of these 2 points. So you can use similar to the cell phone positioning, but really where you are in this kind of very big circle, so you can be anywhere there with just 2 satellites. A third satellite narrows it even more, but you actually need 4 satellites, so you need 1 more satellite to do the positioning. Then you can use the cell towers, and this is because I really oversimplified things here. So the basic intuition is here, all that I said, but many complicated things are happening. First of all, time dilation. You have the relativistic effects. So the satellites are moving very quickly. And when you move so fast, the time in the satellites moves at a different pace than the time on the Earth. It has to be compensated somehow. The other problem is this height information. So you need the 4th satellite to get the height information because not everything is flat on the Earth. Another reason for the need of all of them is, and maybe the biggest one, satellites have very, very precise time. They use atomic clocks that I think lose 1 second every 100 years or so. My car watch now is 10 minutes off, and I set it up in summer. So anyway, so very, very precise time, but your mobile phone doesn't. In this example, we assume that your mobile phone is in perfect sync with these satellites on the sky, which use very, very expensive atomic clocks. It doesn't. So the 4th satellite uses also a correction function. It's just, okay, if your phone time is off, maybe 10 milliseconds or whatever, 10 seconds, then the calculation won't work. So the 4th satellite figures out, okay, what is the time of this guy's phone? It doesn't really figure it out. The phone figures it out, but it figures it. So satellites don't receive anything from you. You cannot be located by anybody using the GPS satellites. The phone does all the calculations, receiving everything there. So when it gets the information from the 4th satellite, it sees that, okay, my time is off. So it does also some correction there. So really many complicated things are happening. But if you live in a perfect world where you don't have these kind of different problems with the time issues, then this simple system should work. Why I talked about all of this is I think it's interesting, but also you will see that we will write now a few lines of code to get our location in HTML5. And these few lines of code do all of this. They actually do all the GPS stuff, all the cell phone triangulation if the GPS is not available, the Wi-Fi positioning, even some few other things that I didn't talk about. And you just get it by writing a few lines of code, and it's like a given. So I think it's good to know that what is indeed happening there took many years to perfect, and yeah, you are basically building very complicated applications just because this is behind your applications here. Right, so I will write one more thing. So one more program, and hopefully this one will go a bit faster.
Yep.
Okay. New HTML file, I call it Geolocation. I'm going to copy from the orientation file into Geolocation file because it just has almost nothing I need. Yeah, I don't think I need anything from here. I keep the output, so let's keep this output here, and now the script, and I can remove the style from here. We just keep it simple this time. So for the geolocation, we need the variable. We just set it to empty. And now this is a check to see if the browser is, if the device is capable of geolocation. If not, then you have to warn the user because it's not going to work. So okay. So they are just attributes that exist if the browser supports it and if the device supports it. Then this geolocation value is going to become something. Otherwise, it's going to stay to null. So now, if the geolocation is something, we can do something. For example, we can get the current location. So and now this function that gets the current position needs again another function to be called when the location is retrieved. So placeholder on location update. And I'm going to write what happens here, same as before. But before, it was for the orientation. Right. And now I'm going to teach you how to use the console in Chrome. It's going to be faster. The console is that thing on, it's one of those things on the right that I used before. So I had the orientation example, now I have also the geolocation example. The console is here, it's on the right. And it doesn't work. And the reason why it doesn't work is that location only works in secure websites. It needs to have HTTPS in front. Luckily, the CS server has the ability to have HTTPS in front. I don't know how to do it myself, but it's possible. So if you are a server manager, then you should know these things. I don't. But luckily here it works, so I can try it. And this is the console log that I printed here. So what has happened is that geolocation was not null. It did become something. And then it got the current position. And when it got it, it printed all the information available in here, in this console. So the console is really nice because you can click on these objects and see them on the right. This is called JSON. We will talk about it much more later. But anyway, you can see that I'm getting some latitude and longitude information. Nothing about altitude. Something about accuracy. Out of curiosity, let's see what this means. So I'm going to put the latitude here, and I'm going to put the longitude also here, and I'm going to search with Google. So, well, not bad. It's this is a laptop, so it doesn't have GPS sensor, and I'm not outside, and somehow it's calculating a distance. I didn't expect this, by the way. Okay, so laptop also has, so in this few lines of code, all these things are happening, what I mentioned before. GPS stuff, cell stuff, even some IP-based positioning. So your computer has an IP that connects to the internet, and there is also some information there about the service provider. Probably this information comes from here. That's why it's in such a strange place. I think this is, yeah, this is, Prisma is here. I think this is the place where Doc Money is and the other things. There might be some kind of service provider there in this kind of area. But anyway, let's see what the mobile phone does. And for that I'm going to use TeamViewer, and I'm going to connect to my own phone. So this one. And I just want to somehow share the screen from my phone. So I really hope this is going to work, because now I'm like sharing screen in 10 different places, and no idea how it's going to behave, but okay. Yeah, so something is here. So this is my phone. Yeah. I have Pokemon Go there, so it should be visible to everyone that I did test the app. Right, so let's see, I open the browser. It already has this orientation example. So this example is there. I played with it in the break. I move now my phone up and down, and basically it moves that circle up and down. So it might be a bit confusing, but the circle on the screen is on my phone screen, so you might, well, anyway, it kind of works. And by the way, this is also how those games work, that you are having a driving simulation and then you move your phone, you rotate it left and right, and it acts like a steering wheel. So really, I think learning this is quite useful, even though it didn't solve our positioning problem until the end. So now this geolocation example. All right, we are not printing anything. Whoops. So I'm writing here to console this information, but I'm not putting anything in my output. So let's put in our output quickly so now have to be careful if I remember correctly. So here I'm going to show you, to be sure. The event object has another object called coords inside and a timestamp. So I have to get the event coords, and then let's just print everything quickly. When do courses end, by the way? Do they end at 15 before, or do they end at sharp? It's maybe something I should know. Tell me, please.
I mean, with the 10-minute break, 5 minutes to before.
Okay, yes, so I have enough time. Okay, so let's make another output here, a bit messy. And iterate again, but now we iterate through the coords object. So I want to print out all of these attributes. So similar to before with this separator, and so the name of the attribute and then the value of the attribute, and then this empty line, and now this string output goes here in the output, and we have an error. And luckily this console is telling us also when we have an error. It says that inner HTML is not a function. It's not a function, it is a attribute. So I'm not going to call it with that parameter. If you use something called jQuery, then it's a method, so then it works like I wrote it, but we don't work with that now, not yet at least. Okay, so now I have the values here, and going back to my mobile phone. So this is now the location of the computer on the left, and now still doesn't work, damn it. All right. HTTPS. The problem on the phone is that I don't have a console here. At least I don't know how to make it come up. So debugging on mobile devices is not so easy to do. Okay. I'm zooming in on my phone somehow. So different location here. I also have some altitude information. I don't think it's very accurate, but quite accurate. Definitely it's not 5 kilometers in, oh no, that's accuracy, sorry. Oh no, I don't have, oh yeah, I have, okay. I don't have altitude accuracy, but I have altitude. So I think Joensuu are about 80 meters above sea level. So this is 99, pretty good. And the coordinates, they are a bit different. So I'm just going to try to type them to see where we really are according to Google. I'm going to go here, the same place, and I'm going to type to see where we are put. So 5981, this is enough. All the others are just better precision. And 29.7437. And this is Science Park. So pretty good. Yeah, what it's using, I have no idea. I assume a combination of the cell tower, some Wi-Fi positioning, a lot of different things, but your code doesn't show it. And it's just this small code that you can use to get your location, and it seems to work, but it's a black box, so you don't have the control to really know where it came from and how it went.